SpaceX's Crew Dragon genius inside design just humiliated Russia's Soyuz. The Russian Soyuz spacecraft has been the longest-lived, most adaptable, and most successful manned spacecraft design. In production for over 30 years, more than 220 have been built and flown on a wide range of missions. Even though the design was expected to remain in use with the International Space Station well into the next century, nobody saw SpaceX entering the picture and blowing the world away with its Crew Dragon, making the Soyuz look obsolete and outdated. The era of SpaceX is upon us, and the era of Russian space dominance is truly over. Today we're going to talk about the SpaceX Crew Dragon and how its ingenious design has humiliated Russia's Soyuz. What is so special about SpaceX's Crew Dragon? Does this mean the Russian space program is under threat of extinction? Well, stick around until the end as we answer these questions and more. So let's dive right in. 2 cosmonauts and a NASA astronaut undocked from the International Space Station and plunged back to Earth in April 2021, landing on the steppe of Kazakhstan amid preparations in Florida for the launch of another station-bound crew Thursday aboard a SpaceX Crew Dragon spacecraft. Meanwhile, NASA astronauts Bob Behnken and Doug Hurley will embark on a spaceflight of a lifetime, heading over 250 miles above Earth's surface on an entirely new vehicle that has never been flown by humans before. SpaceX's Crew Dragon capsule, a modified version of its Cargo Dragon capsule that has delivered cargo and supplies to the ISS since 2012, is unlike any other previous space vehicle. Here's the difference between Crew Dragon and the now extinct Space Shuttle and the Russian Soyuz capsule. The only spacecraft currently capable of launching humans to the International Space Station. Russia's workhorse Soyuz spacecraft has been flying for nearly 45 years, ferrying the first cosmonauts into orbit, and then branching out to launch NASA astronauts and space flyers from many countries on trips to the International Space Station. The Soyuz spacecraft was designed in the 1960s by S.P. Korolev Rocket and Space Corporation Energia. It replaced the Voskhod spacecraft. The Soyuz spacecraft was launched atop the Soyuz rocket, the most widely used launch vehicle in the world. It was fired from the Baikonur Cosmodrome in Kazakhstan. The spacecraft was originally developed for the manned lunar programs of the Soviet Union. It currently serves the International Space Station. Soyuz 1, launched in 1967, was the first in the series of the Soyuz spacecraft. The Soyuz spacecraft has 3 modules: the orbital module, service module, and re-entry module. The orbital module is the spheroid-shaped forepart of the spacecraft. It has the key equipment, cargo, docking avionics, communication gear, and a forward view window. It has an internal volume of 6 cubic meters and a livable area of 5 cubic meters for accommodating crew during missions. The cylindrical service module is equipped with instrumentation and propulsion systems and solar panels. It has an electrical supply, temperature control, radio telemetry and communication, control, and orientation control systems in a pressurized compartment. The propulsion compartment is non-pressurized and houses the main engine and propulsion systems. The external sensors and low-thrust engines of the intermediate compartment enable the orientation of the satellite and solar panels. The re-entry module of Soyuz is an aerodynamic compartment that allows the re-entry of the crew into the Earth's atmosphere. It has about 4 cubic meters of internal volume and 2.5 cubic meters of usable space. It has a heat-resistant shield and main and braking parachutes for a soft landing. The internal atmosphere is maintained through KO2 and LiO cylinders. The spacecraft can provide life support for 30-person days. The noise-fairing system that jettisons after entering the atmosphere also provides protection to the vehicle. The spacecraft also has an automated docking system. The operation of the spacecraft can be independent of ground control or by the pilot. Launching to ISS docking of Soyuz takes about 2 days. It returns to Earth in about 3.5 hours. Soyuz is provided with a thermal control system, life support systems, power supply, onboard complex control system, combined propulsion system, docking system, motion control system, Kerr's rendezvous system, teleoperator control, Soyuz launch escape system, portable survival kit, landing aids kit, and entry actuator system. It is also equipped with a KVANT-V and RASFED radio systems, orbit radio tracking, onboard measurement system, and KEOLUST-M television system for tracking and communications. The visual and optical devices include a docking light, VSK-4 periscope, pilot sight, laser rangefinder, and night vision device. So are you guys having a good time learning more about Russia's Soyuz aircraft? Tell us something. What does SpaceX's Crew Dragon offer in terms of engineering excellence? What is the design philosophy behind it, and how different is it from the Soyuz? Do you have any answers? What do you think? Do subscribe to our channel and click on the bell icon to receive instant notification about all our future videos. Elon Musk says human spaceflight has always been the fundamental goal for his pioneering company, SpaceX. The entrepreneur achieved that ambition on Saturday, 30 May 2020, when the Crew Dragon spacecraft carried NASA astronauts Doug Hurley and Bob Behnken to orbit for a rendezvous with the space station, or ISS. It was the first crewed vehicle to fly from U.S. soil since the retirement of the shuttle in 2011. When the space program ended, NASA had no immediate replacement vehicle. This left the space agency reliant on Russia to fly American astronauts to the ISS. In the meantime, however, SpaceX and Boeing worked on developing vehicles to take over that job. Crew Dragon is now making routine visits to the orbiting outpost, and as of September 2021, is also being used for fully private missions that carry amateur astronauts to orbit. Musk's vehicle evolved from an earlier spacecraft called Dragon 1, which has launched 20 times the missions to deliver cargo to the ISS. The Crew Dragon is a capsule design, like the Apollo command modules that carried astronauts to the moon. From launch up until shortly before re-entry, the capsule is attached to a section called the trunk, which has solar panels, heat removal radiators, space for cargo, and fins to provide stability during emergency aborts. Together, the capsule and trunk stand around 8.1 meters tall, with a diameter of 4 meters. The Crew Dragon is equipped with 16 Draco thrusters that maneuver the vehicle in orbit. Each Draco is capable of producing 90 pounds of force in the vacuum of space. If anything goes wrong during liftoff, the capsule has a launch escape system consisting of 8 Super Draco engines that each produce 16,000 pounds of force. The LES quickly separates Crew Dragon from its rocket. The company wanted to make Crew Dragon feel like a 21st century spaceship. Probably one of the biggest features of Dragon is the touchscreens on the inside. They were designed not just to be very functional, but with a user experience in mind. The 3 large touchscreen displays that allow the commander and pilot to monitor and control the spacecraft are a world away from the analog buttons and dials in the cockpits of previous vehicles like the Soyuz. As the first humans assigned to fly in Crew Dragon, Hurley and Behnken worked closely with SpaceX to get the capsule ready for its historic launch in May 2020. The crew members, who had both previously flown on the shuttle, provided vital input. For scenarios where astronauts might need to assume manual control of the normally autonomous craft, such as finishing off a docking sequence with the space station, the touchscreen controls are much more than adequate. The capsule design is safer than a winged vehicle under most circumstances. Crew Dragon is also designed to be too fault tolerant. This means that if any 2 things fail, such as flight computer and a thruster, the spacecraft can still bring the crew home safely. During missions to the ISS, the SpaceX vehicle docks with the orbiting outpost autonomously, that is, without having to be guided in by a human. There are GPS sensors on Dragon, but also cameras and imaging sensors such as LiDAR on the nose cone as it's approaching the space station. All of these sensors are feeding data back to the flight computer. The flight computer then uses algorithms that determine, based on this information, how to fire thrusters to most effectively get to the docking target. So, how much of an improvement do you think the Crew Dragon is over the Soyuz? Let us know in the comments below. And if you want to watch more of our amazing videos, then stay tuned.